So without layer 2, focusing on layer 3 is not that good. Directly getting into routing protocols, it may give you kind of learning experience, but this is the proper approach. Understand layer 2, understand layer 3, and then the other things like virtualization and so on. So when we talk about layer 2 switching, what should come in our mind is the 48-bit address. The MAC addresses are unique address. They are unique to each device, in which the first half is talking about the vendor of the device, the second half is talking about the count of the device. Those things are not that important, but what is important is its 48-bit size. Even in MAC address, you got multicast address, broadcast address, and so on. Like you have an IPv4 or v6 address, unicast, broadcast, and multicast. Even in MAC address, you got broadcast address. The broadcast address, the layer 2 broadcast address will look like this: FF. This is how it will be. 12 times F. We know, according to the number system of hexadecimal, F is the biggest number. So all the bits are on now, which means this is the biggest number in hexa. 48-bit binary is written in this format. 12 times F. This cannot be a MAC address of any particular device. This is for all devices in that LAN. Any traffic that is destined to this address will reach everyone in that LAN. So MAC addresses also have got broadcast address. In layer 3, what is the broadcast address? 255, 255, 255, 255. Here also, if you see, all 8 bits are on. This is the biggest number out of 32 bit you will get. It's a broadcast address. And in layer 2, we do have multicast address. If you see multicast address, this portion will have 5E. Forget about the other numbers. If you will have some number 5 right in the middle of your MAC address, you should know that it's a MAC multicast address. It's a layer 2 multicast address. There is no need to know much about this. If it is needed, I'll let you know whenever it comes. But as of now, how do you identify a layer 2 multicast address? You will see 5E. For example, let's see. When you have a layer 3 multicast, for that, layer 2 multicast will be having 5E. But these are all reserved, these are all exceptionals. Whenever we do IPv4 multicasting, for that you will have 5. This is what I was talking about, this range of multicast address. That is what we need to actually know. There's no need to know these multicast address, not that important. But we will be learning IPv4 multicasting. For IPv4 multicasting, this is what the clue. This is how you can identify that this traffic is a layer 2 multicast because there is a layer 3 multicast. Alright, now let's go back to our understanding of switching topic. So in IPv4 world, the multicast address will begin with 224.0.0.0 till 239.255.255.255. This range is IPv4 multicast range. We'll talk about IPv6 separately because there are a lot to learn there. About the unicast, you don't need to worry about it. Every MAC address is unique in MAC address. Every MAC address, every layer 2 address is unique. So we do have a broadcast address, we have a multicast address, some are reserved that may have C in this place instead of 5E. But when you use IPv4 multicasting, the equivalent layer 2 multicast address will be having 5E. It is because of this 224. If you convert, you will see 5E there. Not necessary to go that deep. You need to just know it's 5E. Next. Switches or single broadcast device. Single broadcast device. Switches or single broadcast device. What does it mean, single broadcast device? All those devices that you connect to this box will form one big group. There won't be any secret in between them. Everything is available for them from other. If A wants to know about K, it knows. No one can stop. A wants to know about M device, it can know. Because they're all in one room. They're inside the same room. They're inside one broadcast domain. But even though they are in same room, because it's a switch, they got one-to-one reachability. Meaning, if A wants to talk to K, it can go directly and talk. A need not to shout. A knows who is K. If you take it as a room, A knows in which bed K is sleeping. It goes straight to K and talks to K. It won't shout so that everyone will get disturbed. No, it's not going to disturb everyone. But if A don't know where is L, actually L is here, but A don't know that L is here. L is connected to this port. Assume A, K, L all MAC addresses of device. If A don't know where the MAC address L resides, only then it will use the broadcast. See, it has got one broadcast domain, meaning if it shouts, if A shouts, not only L can receive, everyone will receive. We call it as broadcast. So whenever there is a destination which is unknown to the switch, switches will broadcast. Unknown destination. Unknown destination, packets will be flooded. It will flood to all the ports except from where it is originating. Except from the port it originates. So if A is sending a packet with some destination address L, if switch don't know where is L, what switch will do is it will flood it to every port except from where it is coming. That is how switches will do for unknown destinations. Flooding to all the ports except where the port is originating. For that, this one broadcast domain is needed. One broadcast domain. Switch has got one broadcast domain. What does it mean? It has got one controller to control this group of ports. One controller. So if you send the packet to that one controller, it takes the responsibility of flooding it to all others. But when you have the MAC table with port numbers F0/1, A is connected, F0/11, K is connected, F0/24, M is connected. M is the MAC address, assume. I said MAC address is 48-bit. For our easiness, I am writing a small character. Now, C, A, K, M is already known. For well-known destinations, it won't flood because it's a known destination. It's not an unknown destination. Only for unknown destination flooding. For known destination, it knows where is K. K is on port number F011. So it can go straight to K and deliver the packet. This avoids collusion. If you simply flood all the time, the collusion will be more. But because we have learned the MAC addresses, we are not going to flood all the time. The switch is not going to flood all the time. As a result, the collusion is controlled. See, every port is learning MAC address. That contributes in collusion control, correct? So, if it is 24 port, we say 24 collusion domain. 24 collusion controller we have. Each port listens, learns the MAC address. As a result, we avoid flooding. When you avoid flooding, collusion is avoided. Right? So, broadcast domain, collusion domain. Next. This broadcast domain can be broken down into pieces in order to have small groups. Right now we got 24 port switch, but what if you have 300 port switch? 300 port. If you keep 300 port in one broadcast domain, this controller is difficult to manage. The domain is too big. Right? The domain is too big. Let's say there is a new leader for a classroom in your school when you learn. This new leader is a very soft guy. He cannot even shout. His voice is very low. Please be silent. Don't talk. Do you think he can control the class of 50 members? Not possible. But if it is a class of 10, he can still manage. He can manage. Even though his voice is low, You can still manage because it's just a class of 10. So what we need to do is we need to take the class of 50 and we need to have 5 sections. 8th standard first, or 8th standard A section, 8th standard B section, C, D, E, to multiple sections so that it is easy to control. If someone is shouting, when class is shouting, it is easy to control. Exactly the same story here. If all the devices starts broadcasting at the same time, very difficult to control. Not only that, if all 300 devices are in single group, then all 300 can look into, first computer can easily get into the 300. Everyone will be like an open book. So you cannot divide them into different departments. If you have multiple departments, you want multiple groups. You cannot have the entire office in one big network. Why? Because in an office there are many departments. So we also need many groups so that one group will not interfere with the business of the other group. One department will not disturb the other department. How can we do that? We need to create more broadcast domain. We need to take this one big broadcast domain that has got 300 ports as a member. We need to take this and we need to divide into multiple broadcast domains. For example, in that office, if I'll have departments, each department of 25 people, then I need to create many small broadcast domains. I'll say broadcast domain. To identify the broadcast domain, I give 10, and this 10 is for sales. How many ports? Starting from F0/1 to F0/25. Next broadcast domain is identified with number, let's say 20. Production. Starting from F0/26 to F0/50. Now all these ports are in one group, these ports are in different group. F0/1, F0/25, F0/26, F0/50, F0/51, F0/75, like this. This is in one group now. Let's say 30 marketing, 20 production, 10 sales. Groups. Now if there is any broadcast coming to this port, or if the packet that is coming is unknown to this VLAN, to this group 10, say a packet is coming to this port here, let's say F0/16. The destination of the packet is unknown. So flooding will happen, but not to all 300, but only to these 25. The packet will be flooded to all these 25 ports. What is the advantage? Advantage is unnecessarily we are not disturbing production and marketing. See, this port belongs to sales. If any traffic is coming, it is coming for sales only. Why should we flood it to production and marketing? So we don't unnecessarily utilize the process of other department. As a result, the efficiency of the network goes up. So breaking down this one broadcast domain into multiple broadcast domain has got this advantage. What? It improves the efficiency of your network. When you put 50 people of class into five sections, the teacher can teach the students very well, because the student strength is only 10. When I was grown up, none of my class has got more than 18 from my childhood to my college days. But here in Bangalore, I hear that like a sheep and the flock, and they are like 50, 60 in a class. I don't know how children can be managed by one teacher. In colleges, there are 60, 50. I never had such experience. Students can't learn if it is a big group. Teachers can't focus on everyone. Fine. Same story here. If all 300 are in one group, it is very difficult to manage. The efficiency will go down. When we break down into small groups, when we create more broadcast domains by giving some ID number, this broadcast domain is 1, this broadcast domain is 20, this broadcast domain is 30. When we group them like this, the broadcast that is hitting the port will be local to that broadcast domain. It won't impact the other broadcast domain. In that way, the efficiency of the others goes up. They are not disturbed unnecessarily with other department packets. The other important advantage is the bandwidth utilization also improves. If all 300 are in single group, the flooding goes to even these departments, which is not really relevant. The flooding generated by this department, why it should go and consume the bandwidth of other department? Not fair. If it does, it is wasting the bandwidth. But because we have grouped them into small groups by creating more broadcast domains, because we have grouped them as small groups by creating more broadcast domains, what happens is the flooding is localized within the group. Bandwidth of the other groups are not unnecessarily consumed. Bandwidths are not unnecessarily consumed. Yeah. So it is good to create more groups. There is another very important reason why we need to group like this is security. If the sales person tries to know what is going on with the production or marketing, not possible at all. Just by using one switch, it is not possible. If sales wants to talk to marketing, it needs to go through a router where you have ACLs to decide whether to permit or not. So the sales department has got security. No one can enter into sales without layer 3 approval, without routing, without a router allowing through an ACL. It's not possible. Likewise, production is safe. Production people are safe. They know that sales cannot interfere, marketing cannot interfere. They are fully isolated and protected. The group members are in one secured ring. So grouping like this by breaking down the broadcast domain is recommended. Breaking down this broadcast domain or having this multiple group is possible because of the feature called VLAN. This is what we call it as VLAN. What you learned so far as a group, small broadcast domain, or breaking down large broadcast domain into small broadcast. This is what we call it as VLAN. This is what VLAN number. VLAN 20, VLAN 30, VLAN 10. 10 is the number to identify the broadcast domain. See, the actual story is creating broadcast domains. But for our easy understanding, they have given another word called LAN. See, this forms one LAN. This forms another LAN. This forms another LAN. But basically it belongs to this switch. Switch is a LAN to which all the ports are member. But this is not a switch, but by creating broadcast domain we are creating a virtual switch. That is why this LAN is also called as VLAN. A switch is a LAN device and a VLAN is a virtual switch. One switch will have one broadcast domain. When you create more virtual switch, you get more broadcast domain in a physical switch. So you got more virtual switch in one physical switch. Yep. So VLANs are very important. What is the advantage of having VLAN? We can reduce the size of the broadcast domain. Why should we reduce? To improve the efficiency of your layer 2 network. How? By limiting the broadcast within the department, we don't unnecessarily utilize the bandwidth and the process of the other departments. In that way, it improves the bandwidth and improves the efficiency of our network. Not only that, it provides security between the departments. They have isolation. So, having small LANs are always good advantage than having as one big LAN. One big LAN very difficult to manage. Now for this VLAN, virtual local area network, we have some bit reservation, which is up to 12 bits, not more than that. So VLAN can be only up to 12 bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And by default, this is on. And all the remaining are off. So there is a default VLAN called 1 to which all the ports are mapped. Yeah. So there is a default VLAN, meaning there is one broadcast domain in a switch by default, because all the ports are member of this default VLAN. But if you want to create more groups, you can go like this: 1 here, 0 here. All the rest are 0. So what do you have? VLAN 2. This is VLAN 2. You can have up to all the bits are on. What is the number you get? VLAN 2. This is the maximum VLAN that we can create. But again, there are some reserved VLANs. You will not be allowed to use 4096. You will not be allowed to use some 1024. For a few services like fiber channel, token ring, some VLANs are reserved. That you will see when you type show VLAN brief. Even when you don't create it, will be there already created. Those reserved VLANs, you don't need to worry, you don't need to remember. You will see them already there created, but no interface mapped. So what's the maximum VLAN we can create? 4096. Why? Because the number of bits for VLAN is 12. You see, let's use the calculator and see. 2 to the power of 12. 4096. That's the maximum number of VLAN. Nowhere on earth you can create more than 4096 VLANs. Not possible. VLANs not possible. But it may be too early what I'm going to say now, but try to understand. Today's network growth has reached to a very high level. Not like 10 years before or 15 years before. It is totally different network today. Big changes have happened. Cloud networking, cloud software defined, lot of things have come. So we will not be satisfied with this 4096. We need more. For which VXLAN has come, which we are not going to go into now. But just for your information, I'm saying with VXLAN you can have 16 million groups, 16 million broadcast domains. For now, let us not get into VXLAN. 4096 is the maximum number of layer 2 separations you can do. Layer 2 domains you can create. 4096, that's the max. Right. So we have learned about what VLAN is and why VLAN is. VLAN is nothing but broadcast domain created inside switch. More broadcast domain, more control over the network, because more groups, more it will be more smaller. I have 50 students. When I'm allowed to create more groups, what I'll do? I'll create 5 students in a class. So efficiency will improve. More groups, more broadcast domains, more VLANs, more effective. Optimum utilization of bandwidth, improved bandwidth, security, optimum utilization of processor, no wastage of processors. A network will also be faster when you group. The syllabus of the class can be easily covered by the teacher very fast if number of students are less. More students, more doubts, more things the teacher need to answer. Why more doubts? Because it's more student, more noisy. When teacher speaks, and people some cannot hear, they ask questions, so she has to repeat again. Same thing happens here also. If it is more, some packets get lost, so it needs to be retransmitted. Sometimes packet timed out. So more VLANs, more efficient your network is going to be. Next, this VLANs that we create on one switch need to be created on every switch if you want the members of the VLAN to communicate. For example, I have a switch here, 1, switch 2 here, and switch 3 here, and I'm combining this switch. How many switches we got? 3 switches. How many broadcast domain we got? Let's say we did not create any VLAN. We will have one default VLAN, no? In all these 3 switches, we will have one default VLAN. So how many broadcast domain we have in this 3 switch? Not 3. Only 1. Only one broadcast domain. Why? Let's say this is port 10. This belongs to which VLAN? VLAN 1. And let's say this port is port 20. Belong to which VLAN? VLAN 1. Likewise, this port 40. This port F0/15. They all belong to same VLAN. So when any packet comes and if it needs to be flooded, it will go to all the port including this F10. When it goes here again, it will be flooding to all the ports and it will go here. The flooding goes up to here. Just one broadcast that is generated here is flooded throughout the office because they are all in one big broadcast domain. They all form one big broadcast domain. So what we do is we create VLANs, VLAN 10, VLAN 20, VLAN 30, VLAN 40, so that instead of impacting all the members of this office, if any flooding happens, let's say this port belongs to VLAN 10, it will go and impact only VLAN 10 members on all switches. If there is VLAN 10, it will go here. If there is VLAN 20, it won't go. The flooding that goes will impact only VLAN 10 members. All the ports of VLAN 10 in different switch, they combine to form one virtual switch. That is what VLAN is. All the ports of VLAN 10, though they belong to different physical switch, they all form one virtual switch, one switch. Now what I was trying to say is, let's say you got VLAN 10. Earlier I started something and What I was trying that time is, the VLANs that you create on one switch, you should create on all the switches. Let's say I don't have this VLAN 10 is sales department. I don't have any sales member here. No sales member in this switch connected. But there is a sales member connected here. If I want to ping between A and B, you must have VLAN 10 created here. If you don't have VLAN 10, let's say you don't have VLAN 10 here, you got VLAN 10 here, you got VLAN 10 here. The ping will not happen between A and B. A cannot ping B. Why? Because the switch in the middle don't belong to that broadcast domain. So when VLAN 10 packet comes here out, the switch 2 will say, I don't have VLAN 10. I cannot accept this packet. If it don't accept, then how it will send it to the next switch? Not possible. So the reachability between A and B will never happen if you don't have VLAN 10 in the middle. Even if you don't have sales member, you should simply create VLAN 10 so that when VLAN 10 packet comes, switch 2 will accept into VLAN 10 domain and send it as VLAN 10 outside. And here it is received as VLAN 10 and sent to VLAN 10 members. So what I'm trying to say is, if you have VLAN 10 members in various switches, make sure the VLAN 10 is created in every transit switch. So not only on the switch where the sender and receiver is, you also need to have those VLANs to be created on every switch in the transit. Only then the reachability will be there. Now, what if I have 100 switches? Yes, you need to have on all 100 switches this VLAN 10. Only then the members who are scattered here and there in various switches, the VLAN 10 members, will be reached. To create this VLAN on all 100 switch, there is an easy way. In Cisco, there is an easy way. The other vendors don't have this. In Cisco, it is easy. You just create on one switch that gets replicated to all the other switches immediately. For that, we enable a service called virtual VTP trunk protocol, VLAN trunk protocol, not virtual, VLAN trunk protocol, VTP. This is a Cisco proprietary protocol. The job of this protocol is to replicate VLANs. Now this VTP will not be on by default. We have to on it by giving a domain name. VTP gets on when you give VTP a domain name. What is domain? Controller. You need to say which all switches will form one group, one control, one VTP control. So you need to go to those switches where you want the VLAN to be copied and give same domain name. You cannot have different domain name, same domain name. VTP domain name. When you give domain name, VTP gets up. It starts working. But that only is not sufficient. For this replication to happen, these links need to be a trunk link. All of you know what is trunk link. Trunk link is a link that can carry multiple VLAN traffic. Multiple VLAN traffic. So when you got a trunk link and when you got the same domain name in all these three switch, the replication of VLAN is going to happen. So when you delete this VLAN 10 here, the VLAN 10 will be deleted in every switch. When you add VLAN 20, 30, 40, in all the switches VLAN 20, VLAN 30, VLAN 40 gets created. Automatically it gets created, replicated. That's the power of VTP. So you have 50 switches, you don't need to log into each switch and put these VLANs. Just once, you go to all the switch, put the domain name same and enable trunk between the switch. Enable trunk. That is why it is called as trunk, VLAN trunking protocol. Only when you have trunk and the domain name common, the replication will happen between inter-switch link. This is not a protocol, this is inter-switch link I am writing in short. Yep. Alright, about VTP we have some more story to tell. VTP has got 3 versions and there is something called revision number. We'll talk about that, different modes of VTP in our next class. Do you have any question on what we have covered? Today we have covered just the introduction to switching. We have virtual switch, we have physical switch. And switches deal with MAC address, not the IP address. About the MAC address we learned like it is 48-bit size. Multicast MAC addresses for a multicast IPv4 address will be having 5E in the middle. The broadcast addresses will have FFFFFF. And then we learned the collision domain and the broadcast domain. We learned that breaking down large broadcast domain into multiple broadcast domain as VLANs, and that improves the efficiency of the network, improves the bandwidth, improves the process, optimum utilization, and so on. For VLANs we got 12-bit, so maximum VLAN you can create is 4096. To replicate VLAN we have VTP protocol. For VTP to replicate you need a domain name common and trunk between the switches. Any question you may ask now. Any question?